Welcome to EDU World Space.
Okay, so we're in chapter 32, problem 20. So this problem wants us to use two techniques. First, a ray diagram, and secondly, the mirror equation, to show that the magnitude of magnification of a concave mirror is less than 1. So we'll show magnitude of the magnitude of the magnification is less than 1 if the object distance is greater than the radius of curvature, and then that the magnitude is greater than 1 if the object distance is less than the radius of curvature. Okay, so first let's do this with some ray diagrams. So let's draw our plane here, and this is be our mirror. We'll set this as 1 focal length. And this is 2 focal lengths, which is the radius of curvature. So for the first case, we want the object distance to be greater than the radius of curvature. So let's put our object over here. And now let's first do the parallel one, which comes in parallel to the plane, and then it'll bounce back out through the focal length. The next one will go through the focal length and back out parallel. And if I drew this right, these will meet up about here, which will be our image. So this shows us that the image will be shorter than it was before, which means m is less than 1. Cool. So now let's draw the second case. So we'll draw our mirror again. There will be the focal length. It will be the radius of curvature. So now let's put our object right here. So our object. So we have a parallel line coming in. And now this is going to go straight through the focal length and back out. Now let's go through the focal length. And this one is going to go straight back out. So we're left with right here our image. And we should see that this image is now bigger than the object. So the magnification is greater than 1, which is exactly what we wanted to show. Awesome. So now let's add this new one. Let's do B now. So now we want to use the mirror equations. So first, this is write it out. 1 over the object distance plus 1 over the image distance equals 1 over the focal length. And this is the same as 2 over the radius of curvature. So now let's solve for the image distance. And this is given as r times the object distance over 2 times the object distance minus r. Cool. We can also find the plug this into the magnification equation, which is given as this. So if we plug in our expression for image distance, we should be left with negative r over 2 d naught minus r. Cool. So now let's figure out our two cases. First was if d was greater than r. So if d naught is greater than r, that means 2 d naught minus r is greater than r. Okay, so if that means our denominator is greater than our numerator, then we know magnitude is less than 1, which is exactly what we wanted to show. So now let's show the second case of the object distance being less than the radius of curvature. So what this leads now is 2d0 minus r is less than r. So if our denominator is less than our numerator, then that fraction is going to be greater than 1, which is exactly what we wanted to show. Awesome.